Hi friends, I'm Kishore. Now I'm going to give my presentation on handwritten digit recognition using neural networks in MATLAB. First of all, we see what is handwritten digital recognition. The handwritten digit recognition using a neural network with MATLAB involves creating and training a model to identify and classify images of handwritten digits, typically using the datasets which consist of labeled images of handwritten digital digits from 0 to 9. Basically, it's commonly used in applications like postal mail sorting, bank check processing, and digitalized document organization. Such as and here in this process, it's a collection of data, pre-processing, model design, training, evaluation, optimization, and tuning and deploying. Here we can see the introduction to handwritten digit recognition using neural networks in MATLAB. Here the introduction explains like handwritten digit recognition is about identifying handwritten digits and classifying them into neural values like numerical values using neural networks, particularly in MATLAB environment. Like handwritten digit recognition is the task of identifying and classifying handwritten digits into their corresponding numerical values. Neural networks are a powerful machine learning technique that can be used for this task, and the MATLAB provides a user-friendly environment for implementing neural networks and training them for handwritten digit recognition. You can see here the understanding neural networks for handwritten digit recognition. It describes how the neural networks consist of interconnected layers of nodes process images of handwritten digits to predict the corresponding numerical values. Neural networks are composed of layers of interconnected nodes that mimic the structure and function of the human brain. The input layer receives the handwritten digits image pixels, with the output layer provides the predict digit class. Hidden layers process the input data through weighted connections and activation functions to make predictions. Processing handwritten digit images for neural networks. Here it discusses necessary pre-processing steps like normalization, resizing, and noise reduction to improve neural network performance. Pre-processing steps such as resizing, as I mentioned, and it convert the images into grayscale and resizing them to a standard size can help in extracting relevant features. By removing the noise and artifacts from the images can enhance the accuracy of the recognition process. Here the scaling pixel values to a range of 0 to 1 to 8 neural network performance like reshaping the data, transferring image into a format suitable for MATLAB neural network tools. For example, converting each 28 by 28 image into a 784 element vector. It's called data augmentation. It's optional like techniques like rotation, scaling, or noise addition to increase the robustness of the model. Designing a neural network architecture for handwritten digit recognition. It covers how to design a neural network architecture, including decisions about the number of layers and nodes which are essential for effective digit recognition. Here, the architecture of a neural network includes the number of layers, nodes in each layer, and activation functions. For handwritten digit recognition, a common architecture is feed-forward neural network with multiple hidden layers. Choosing the right number of nodes and layers is essential for achieving high accuracy in digit recognition. Training a neural network for handwritten digit recognition. It explains the training process using labeled digit images, focusing on techniques like back propagation and importance of splitting data into training and validation sets. Here, it like training a neural network involves feeding it with labeled digit images and adjusting the weights to minimize the prediction error. Back propagation is a common training algorithm that updates the weights based on a gradient of the loss function. Splitting the dataset into a training and validation steps helps in evaluating the performance of the neural network. Testing and evaluating the trained neural network. After training the neural network, it is important to test it on unseen handwritten digit images to evaluate its performance. Metrics such as accuracy, precision, recall, and F1 score can be used to assess the recognition performance. Confusion matrices can provide insights into the miscalculations, classifications made by the neural network. Improving handwritten digit recognition with convolution neural networks. It introduces like as a more effective type for image-based tasks like digit recognition, discussing the feature extraction and the potential transfer learning. Here like in convolution neural networks simply called as CNNs are a specialized type of neural networks that are well suited for the image recognition task like handwritten digit recognition, and these are used like into convolution layers to extract features from images and pooling layers to reduce spatial dimensions, and it transfers learning where pre-trained CNN models are fine-tuned for digit recognition can help improve more accuracy and efficiency. Here we can see like deploying a trained neural network for handwritten digit recognition. It talks about deploying the trained neural network in real world application, integrating it with user interfaces and the importance of continuous monitoring and updates. As once a neural network is trained and evaluated, it can be deployed in real world application for automatic digit recognition. Integrating the neural network with user interfaces or web application can provide a seamless experience for users. Continuously monitoring and updating of the neural network can ensure its performance remains optimal over time. Here the challenges and future directions in handwritten digit recognition. Challenges in handwritten digit recognition include variation in handwriting styles, noise in the images, scalability to large datasets. In the future direction in this field include exploring advanced neural network architectures, incorporating generative adver- adversarial networks for data augmentation, and integrating with augmented reality technologies. Research efforts are ongoing to improve the robustness and accuracy of handwritten digit recognition systems for various applications. In conclusion, handwritten digit recognition using neural networks in MATLAB offers a powerful tool for pattern recognition tasks. Through careful design and training, neural networks can achieve impressive accuracy in classifying handwritten digits. However, the performance depends on various factors such as network architecture, training dataset quality, and optimization techniques. Continual improvement and experimentation with these elements are essential for achieving optimal results in real-world application of handwritten digit recognition.